At the end of this video, you should be able to determine the existence of limit of a function where the limit x approaches a from the left fx is the same as limit x approaches a from the right fx. Existence of limit. If limit x approaches a from the left is equal to the limit x approaches a from the right, for example, the value is L, therefore, we can conclude that the limit x approaches a for the function fx is equal to L. But if limit x approaches a from the left does not equal to the limit x approaches a from the right, then we can say that limit x approaches a fx does not exist. Let's try example 12. Part A. Based on the given graph, determine each of the following limits. The first one. Find the limit x approaches negative 2 from the left. This is negative 2. And try to follow the graph that less than negative 2. So when x approaches negative 2 from the left, we can see that y or fx is approached to 1. Second, evaluate the limit x approaches negative 2 from the right. Look at the function or the graph that greater than negative 2. And now you can see that when x approaches negative 2 from the right, then fx, the graph, approach to 1. So what we can say about the limit x approaches negative 2? Does the limit exist? Yes, the limit exists because the left-hand limit are equal to the right-hand limit. And the limit x approaches negative 2 fx is equal to 1. Part B. Evaluate the limit x approaches 1 from the right. This is 1 and refer to the graph that greater than 1. And when x approach 1 from the right, we can see that y approach to 1. Next, we want to find the limit x approaches 1 from the left. Look at the graph that less than 1. And we can see that when x approach 1 from the left, then y approach to negative 3. Therefore, we can say that limit x approaches 1 fx does not exist. The one-sided limit is important to determine the existence of limit. Example 13. Find the limit x approaches 0 from the right and the limit x approaches 0 from the left for the function gx, where gx is defined by the first one, x squared, for the interval x less than 0, and 1 plus x for the interval x greater than 0. First of all, try to draw the number line and identify the function of g for the given interval. For x less than 0, the function of g is x squared. And for the interval x greater than 0, the function of g is 1 plus x. Therefore, if we want to find the limit x approaches 0 from the right, the function of g that we need to substitute is 1 plus x. Then, substitute the value of x with 0 and we get 1. Next, find the limit x approaches 0 from the left. And the function of g is x squared. Substitute x with 0 and we get 0. Example 14, find the limit if exists for the limit x approaches 1, x squared plus x minus 2 over the absolute value of x minus 1. If we use direct substitution, then we get 1 plus 1 minus 2 over 1 minus 1, and we get 0 over 0. For this case, we can use either multiplication of conjugate or factorization. So look at the numerator. We can factorize the numerator become x minus 1, x plus 2. But we don't have the common factor to cancel out. What should we do now is define the absolute value. So we get x minus 1 for the interval x greater than or equal to 1 and negative x minus 1 for the interval x less than 1. Now evaluate the limit x approaches 1 from the right. For the numerator, we factorize into x minus 1, x plus 2, and the denominator, we change into x minus 1. Now we can cancel out x minus 1 and evaluate the limit x approaches 1 from the right, x plus 2, substitute x with 1 and we get 3. Next, evaluate the limit x approaches 1 from the left, and the denominator we can substitute with negative x minus 1. So we have the common factor and cancel out. Evaluate the limit x approaches 1 from the left for the function x plus 2 over negative 1, and we get negative 3. What we can say about the limit x approaches 1? Compare the right hand limit and the left hand limit that has been evaluated, and we can see that the right hand limit we get 3 and the left hand limit we get negative 3, which is different value. Therefore, the limit x approaches 1, x squared plus x minus 2 over absolute value of x minus 1 does not exist. Example 15, find the limit x approaches 2 from the right and limit x approaches 2 from the left, where the function f is defined as the following. Hence, determine the limit x approaches to fx if exists. So first of all, we draw a number line to represent the function f. Okay, so for the interval x less than 2, this one, x less than 2, then function f is x plus 6. And then for the exactly at x equal to 2, okay, exactly here x equal to 2, then fx equal to 5. And then for the interval x greater than 2, then fx equal to 2x squared. It means that if we want to evaluate the limit x approaches 2 from the right, so the function fx, we must substitute with 2x squared. Then we substitute x with 2 to evaluate the limit and we get 8. After that, find the limit x approaches 2 from the left, and the function f, we must substitute with x plus 6. Then substitute x with 2 and we got 6 also. Sorry, we got 8. So since the limit x approaches 2 from the right is equal to 8 and this value is the same as limit x approaches 2 from the left, then we can say that the limit x approaches to fx exists. And when x approaches to 2, the fx is approached to 8. Example 16. Find the values of m and n so that the limit x approaches 3 and limit x approaches 4 exists and function f defined as following. Since we know that the limit x approaches 3 exists, therefore limit x approaches 3 from the left is equal to the limit x approaches 3 from the right. Another one, it is given that limit x approaches 4 also exists. Therefore, the right hand limit is the same as left hand limit. Now we need to substitute the function f in order to evaluate the limit. But before that, we draw a number line to represent the function. The first one, we have x less than 3, then the function f is x. For the interval x in between 3 and 4, the function f is mx plus n. And for the interval x greater than or equal to 4, the function f is 2x. It means that when we want to evaluate the limit x approaches 3 from the left, this one from the left, then the function f is x. And if we want to find the limit x approaches 3 from the right, the function f is mx plus n. So this is what we get. Then substitute the value of x and we get our first equation, which is 3m plus n equal to 3. Next, for the limit x approaches 4 from the right, the function f is 2x, and for the limit x approaches 4 from the left, the function is mx plus n. Then substitute the value of x with 4 and we get our second equation, which is 4m plus n equal to 8. Solve these two equations simultaneously and we get our value m is 5. Then by using m equal to 5, we can get the value of n, which is negative 12. So in this video, we have learned that the limit exists if the right hand limit and the left hand limit are the same, but the limit does not exist if the right hand limit does not equal to the right hand limit. That's all for this topic. Thank you.